All right, welcome everyone. Thank you all for coming out to today's Tech Talk on this Friday, October 29th, 2021. Like I said, thank you all for coming. We all appreciate y'all coming to our event today. We have a very special guest with us today, and I'm excited for y'all to hear from him to talk. Today we have with us, sorry, I don't know, this thing is always annoying. There we go. Today we have with us Marc Cohen. He's an American software engineer working on Google's developer relations team in London. His mission is building tools, demos, tutorials, and other educational artifacts to make computing and data science more accessible and inclusive. So I'll now allow him to take the floor to speak, and I'll stop screen sharing.
Thank you, Malaya. Did I say your name right?
Yes, Malaya.
Cool. Hi, everyone. My name's Mark, as you just heard. I'm going to share my screen with you. Let's disable screen sharing. I think I might need some help to allow me to share my screen.
Try again.
Oh, now I think I can. Whatever you did just worked. Thank you.
Okay, great.
Okay, so let me move go down here. Okay, so you should all be seeing a slide that says how the internet works. Hopefully, give me a thumbs up if you see that. Okay,
Yes.
cool. Thank you. So yeah, what I'd like to do with the amount of time we have, and I think it'll be probably on the order of 40 minutes or so, is just give you kind of a quick overview of how the internet works, which is why I called it that title. I find that a lot of people kind of have an idea or have part of the picture in their mind, but not necessarily all of it. And so this is going to be kind of a broad overview, but so we're not going to be super deep, but I will allow some time at the end for questions where we can go deeper on anything you might be interested in. There's a little bit of noise outside my window here. Sorry about that. I hope it doesn't get too annoying. This talk, all of the slides you see in this talk are available at the URL that I have shown at the top, mco.fyi/internet. And someone else maybe can type that into the chat for people who may join later. My brain is unitasking, so if I start typing, my speech will shut down. Anyway, I'm Mark. I'm a developer advocate out of Google's London office. I don't sound like I'm from London because I'm not. I grew up in New Jersey, American expat, living in London now for almost 7 years. So let's jump into it. If you've ever been trying to understand how this stuff works, you've undoubtedly encountered all these acronyms like HTML, URLs, TCP, IP, and it can be a little bit like alphabet soup. And what I would like to do is kind of try to demystify all those terms and all the different layers involved. One thing that I like to point out is that 1/3 of all Americans surveyed did not understand how the internet works. Quite a lot of people think there's no difference between the internet and the web. Yeah, so it's sort of some basic technology stuff. And you might wonder, like, why does it matter? Like, why should you understand how the internet works? All you have to do is really know how to use it, right? When you want to get some, do some research or buy something at a commerce site or whatever it is. Why do you need to know how it works? And the short answer is you don't. You can live a perfectly happy life without knowing the stuff I'm going to be talking about. But as computer science people, IT folks, programmers, anybody in tech, I think it's underpinning almost everything we do. If you think about it, just about every time you touch a keyboard, the internet is in the picture somewhere, and it's helpful to understand what's happening under the hood. In fact, I would say even if you're not a computer science person or an IT person, it's still kind of cool to know how this stuff works because it's a pretty amazing capability. So let's start at the beginning. And what I'm going to do is, I didn't mention this, but if you have questions, please, it's a pretty small group, so please just feel free to jump on the mic and blurt something out. Or if you prefer, you can put something in the chat and I'll try to keep an eye on that, although I'm usually pretty distracted when I get talking. So anyway, feel free to interrupt me anytime. So what we're going to do is basically just walk through what happens when you type a URL or a link address in your browser's address bar. And I think this is a good way to work through how the internet works because it's a scenario we can all relate to. We all do every day, whether it's on our phone or our laptop or whatever. But the other reason I like this exercise is I remember probably not as much nowadays, but a while ago, this was like a very common interview question for Google interviews. People would say, you enter in whatever URL and you hit the enter key, what happens? How does that magic all happen? So it's just a good way to think about, to encapsulate what I'm trying to share with you today. Okay, so what, where, and how. It all starts with a URL. As you saw, I had this URL, https://mco.dev. That's my personal domain server name, /miko.html. Miko is my dog. Used to be my dog, actually. But that is what we call a URL. I'm sure you're all familiar with that term, which is short for Uniform Resource Locator. But what's encoded in that string of characters is everything your browser needs to know to do what you're asking it to do. So it starts with the protocol, HTTPS, and I think of the protocol as the how. So this is how I want my browser to hold up a conversation with the server at the other end of the connection. So that's sort of like, you can think of that as what language do you want my browser to speak when it talks to the far end. The server is the where, and so that's where should it make a connection to start this conversation. In this case, it's mco.dev, and the path is the what. So you've told the browser where the thing is, you've told it how you want it to speak, what do you want it to ask for, and that's what that last part is, the miko.html part. And by the way, I hope this isn't too basic. I have a feeling a lot of you are already familiar with a lot of what I'm going to share today, so I won't be insulted if you decide this isn't this is too much duplication, but I'm trying to kind of build a foundation so that we're all on the same page, and hopefully this will give you some new information at some point at least. Okay, so let's start with the where. That's the first thing the browser is going to need to do before it even starts talking the protocol. It has to figure out how to make a connection to the server, the where part, mco.dev. And the way it does that is it looks for the unique address of the server that you've specified. So it needs to find the address of mco.dev. Now, what do I mean by an address? Every computer on the internet has something called an IP address, which stands for Internet Protocol Address. There are different flavors of these addresses, but the oldest kind, the one that we call IPv4, which is most typically and commonly used nowadays, looks like this, these four numbers between 0 and 255 separated by dots. So you can go ahead into a Google search page and you can type my IP address, and it will, if you're curious, you can do that right now and you'll see what your IP address is. That's the unique number that identifies your computer on the internet. Every single computer everywhere on the internet has one of these addresses. Now, when you want to make a connection to a service like google.com, you don't want to have to know that address, right? Because if you imagine how many different services you access every day, nobody would want to keep track of all these different crazy numbers. And so we need a system that will map or translate a symbolic name like google.com into the underlying IP address. And that's the function of the domain name system. Might be domain name service, I can't remember, but anyway, you'll hear this term DNS. And DNS, the job of DNS is to do exactly what I just said, to map a name to an IP address. So, and I like to think of this as sort of like, if you think of the IP address as being like a phone number, the DNS service is like a phone book. Now, I realize that most of you have no idea what I'm talking about when I have no idea what I'm talking about when I refer to a phone book, because in days of old, when we wanted to call someone, we would open up a phone book and find out their phone number. And that's kind of what DNS does. Nowadays, obviously, we have contacts and ways to do that automatically right inside our devices. But that's conceptually what DNS is doing. There's a site you can click on. I think this might be a hot link. Yeah, if you click on if you visit whatismyipaddress.com, it will tell you your IP address, and it will actually even show you on a map where it thinks you are. So this is a little hard to see. I'm not sure if it's easy to enlarge it, but it's basically got me pegged in London, which is correct. And over here it says my ISP is Virgin Media. I'm in the Camden region of the United Kingdom, all of which is correct. So a lot of information can be derived from your IP address. But anytime one computer, I think the key point is anytime any computer on the internet, and that could be a server, it could be your laptop, your phone, anything at all that's connected to the internet, when they talk, it's a connection from one IP address to another. The names that you use in URLs are purely to make life easier for us humans. The computers don't ultimately care about them. If you wanted to actually examine the DNS system, there's a toolbox here that Google provides. And you can, if you click on this slide, if you visit the slides, you don't have to do it now, but later on, if you click on that slide, it will take you right to this toolbox. And so, what's the Howard University? Is it howard.edu by any chance?
Yes.
Okay, so this is, when I enter this howard.edu right here, it's directly querying the DNS service. And it gives me back something called an A record, which is the primary mapping record. So DNS is kind of a database. It's got all these different types of records, but the one that's used day in and day out to map a name to an IP address is an A record. And this tells me the IP address for Howard University is 54.144.226.101. It also says TTL 1 hour. That means time to live of 1 hour. So if my browser gets this IP address, it should assume after an hour that it's stale and it needs to reacquire it. And this is useful because the mapping can change over time. Okay, that's probably enough about DNS. Let's go to the next slide here. Ports. So when you connect to a service with its IP address, there's a little bit more that you need to specify. And the way I like to think about it is, again, using this phone analogy. If someone called you, now obviously this is really bad because I'm going back like so many years that this may not make that much sense. But if someone calls you now, obviously you're going to pick up because it's your phone. But we used to have landline phones where you would call a number and anyone in that household would pick up the phone. And so you would have to ask, who do you want to speak to? And that's kind of like what a port is in an IP or an HTTP connection. It's a way of saying what service you want to connect to on that IP address, on that server with that IP address. So the most common ports are HTTP and HTTPS. I'll mention a little bit more of what those are. But basically, HTTPS is encrypted, so the S is for secure, and HTTP is unencrypted and clear. So you'll connect to an IP address and a port number. The IP address says which computer you want to connect to, and the port says which service on that computer. Who do you want to speak to on that computer effectively? Okay, so that's how we make a connection. Now, I mentioned there's also this protocol part, which is like how you want to talk. And protocols are simply rules of engagement for communicating. You can imagine human-to-human protocols, human-to-machine protocols, and of course, machine-to-machine protocols. An example of a human-to-human protocol might be when you meet someone, you would say, "Hi, I'm Mark," and they would say what their name is, and you might say, "It's nice to meet you." And so there's all these sort of rules of engagement that humans use that are kind of like protocols, but they're very fuzzy ones, right? They're a little bit vague, and there's all sorts of variations, and our brains work fine with that. Computers tend to want to be very rigid and rigorous, and so machine-to-machine protocols are quite a bit more precise and dictated than human protocols. But a protocol is simply a way to specify how to behave when having a conversation with someone. Now, there are layers to protocols, okay? So we have low-level layer. If I start at the bottom, the network layer, that's like the physical connection. So that might be a cable, or it might be Wi-Fi, or something where you're like, you can get bits transmitted from one place to another, but it's the lowest level. IP is a routing protocol, and what that means is that you can give a packet of information to the IP layer, and the IP layer will get that packet to a destination IP address. Now, the key with IP is it gives a best effort attempt, meaning it's not guaranteeing that it's going to get there. It's just saying, I will do my best. Now, that sounds terrible for something you might rely on to, buy something or take money out of your bank account. Like hearing that, I'll do my best, it's kind of like not good enough, right? Like you want a guarantee. And that's where the TCP layer comes in. That's the layer right above IP. So TCP takes a bunch of data, it breaks it up into these packets, and it tells the IP layer, get this from here to this IP address. And the IP layer will take these packets and send them one after another. They might even take different routes to get to the destination. And then the TCP layer above IP again on the destination will receive those packets and make sense of them, put them in the right order if they came in out of order. But most importantly, it will guarantee everything comes across the network. So if it knows there's a packet, it can tell if there's a packet missing, and it can tell the sending TCP layer, there's a chunk missing, please resend it. So this is how we get IP to be reliable. And then on top of TCP is the application layer, and this can be any application at all. For the web, which is one of the primary but not the only application on the internet, the protocol that's used to send and receive web requests is HTTP, which is Hypertext Transfer Protocol. TCP/IP, you'll sometimes see it as written as one string like this, TCP/IP, and it's just shorthand for a whole bunch of protocols that are used to move data across the internet. An example of HTTP, the application layer, is you might say get and then the name of a file. So as I showed you earlier, the URL was mco.dev/miko.html. The get request might be get me the file miko.html. And so if you think about it, that's the highest layer. If I go back to this chart, the HTTP request is get miko.html. That gets sent to the TCP layer, which says, okay, I've got this string get miko.html. I need to get it to the far end. I'm going to break it up into little pieces. And this string is so short, it doesn't really need to break it up. It would all fit in one IP packet. But if you were sending a picture or a video or something, it would need to be broken up into pieces. The IP layer sends all those pieces, and each hop along the way in the IP layer, there's some low-level network hardware that's being used to get the bits physically from one place to another. So that's the highest level, the Hypertext Transfer Protocol, and you'll typically say get, but you can also say things like put. Can you imagine a case where most of the time when you're reading a website, you're doing gets, but if you're wanting to change something, like for example, if you wanted to buy a book online, you'd want to send a put, which says, I want to change a database somewhere in an e-commerce site. So there's gets, puts, posts, all different types of things. But if you wanted to actually learn more about these protocols, like you can read about TCP, IP, HTTP, there are all these documents you can go to and actually find out the details of these. And I think if you click on this, it actually takes you to the online PDF. These are actually, they look scary, but they're actually not that bad as far as standard specification documents go. So you can find out here all the details about HTTP. For example, here's you can say get, head, post, put, delete, trace, connect. Those are all the sort of verbs you can use. How to make connections, some of the limits on how big messages can be, and basically everything about that governs the use of this protocol is specified there. And there's a similar document for TCP and IP and all the other protocols we talked about. I want to show you a really short video that kind of summarizes how this works. And I said it in words, but I like this video because it shows it in pictures and visuals. So let me just share this with you and let me know if you can't hear the audio.
The way information gets transferred from one computer to another is pretty interesting. It need not follow a fixed path. In fact, your path may change in the midst of a computer-to-computer conversation. Information on the internet goes from one computer to another in what we call a packet of information. And a packet travels from one place to another on the internet, a lot like how you might get from one place to another in a car. Depending on traffic congestion or road conditions, you might choose or be forced to take a different route to get to the same place each time you travel. And just as you can transport all sorts of stuff inside a car, many kinds of digital information can be sent with IP packets, but there are some limits. What if, for example, you need to move a space shuttle from where it was built to where it will be launched? The shuttle won't fit in one truck, so it needs to be broken down into pieces, transported using a fleet of trucks. They could all take different routes and might get to the destination at different times. But once all the pieces are there, you can reassemble the pieces into the complete shuttle and it will be ready for launch. On the internet, the details work similarly. If you have a very large image that you want to send to a friend or upload to a website, that image might be made up of tens of billions of bits or ones and zeros too many to send along in one packet. Since it's data on the computer sending the image can quickly break it into hundreds or even thousands of smaller parts called packets. Unlike cars or trucks, these packets don't have drivers and they don't choose their route. Each packet has the internet address of where it came from and where it's going. Special computers on the internet called routers act like traffic managers to keep the packets moving through the networks smoothly. If one route is congested, individual packets may travel different routes through the internet, and they may arrive at the destination at slightly different times or even out of order.
So hopefully that was helpful in terms of visualizing some of the stuff I was talking about. I think it's pretty amazing that this technology is there working, doing all that stuff every day, and you don't even need to know about it. It's also not a very old technology. The internet itself goes back to, I would say, the mid-60s, I believe. But the application we're all most familiar with, the World Wide Web, came about in the early 90s. And so stuff's only been around 50, 30 years, depending on which component you're talking about. And it's changed everything. Obviously, we're all using it every day on our smartphones and our computers. So it's nice to know about that this exists and a little bit about how it works. Okay, any questions up to this point? Because I'm just about to change gears a little bit. Looks like not. Okay. Just jump on the audio if you have any questions going forward. So we've basically covered how you get information from a server on the internet. And let's assume we're using, so as I said, there's many different applications you can run on the internet, one of which is the web. So the web is an application that uses the internet as its infrastructure. So that's sort of the answer to my earlier question. What is the difference between the web and the internet? Web is an application, internet is an infrastructure. We've talked about how you connect and transfer data. But assuming you want to visit a website, for example, so going back to my URL that you type and you hit enter and it does all that TCP magic and HTTP and it fetches this page. What does that page look like? What's in that page? And that page contains markup language called HTML, Hypertext Markup Language. And I'm betting you all know about this, or many of you know about this if you've ever played around with web pages. But for any of you who haven't seen this, it contains these elements in angle brackets. So we have this H1 is a header, first top level header element, and these slash with the same name is a termination of that element. So this is essentially saying in HTML, here's a picture of my dog and I want that displayed in big text as a header for the page. Then I'm showing an image, I give it the size of the image, and then the source is where I want it to find the image. So you're probably maybe going to guess already that when this HTML is processed and the browser wants to turn this into something you can see, and it bumps into this image and sees this source, it needs to go get that image. And so that means it's got to do another HTTP get operation. So these HTTP functions are not just something you trigger, they can also be triggered by the browser automatically in its attempt to render the content of a page that you fetched. Then I have a P, which is a paragraph element. It has a little bit of text there. And then there's an A element. The A element is probably the one that you encounter the most commonly. It's short for a link. I don't know why it's called an A. Maybe some of you can tell me or have heard. But the A element is a hyperlink. And so it always contains an href option, which is the link, the URL to visit when someone clicks on the link. And then what we call anchor text, which is what you want to display for this link. So if we actually visit the page that we've been talking about, it looks something like this. And there's the heading up here, there's the image, there's the paragraph I showed you, and then there's this link. And I think I can actually go to that page, and I think it's live. Let's see. Yeah, so there it is. And the link, as you saw, is clickable. And if you click on that, it brings you to my blog. If you use Chrome DevTools, that's this kind of nice capability built right into Chrome, where if you visit a page like this, you can see everything that's going on. You can see all the network requests, the performance of the page, any errors that happened along the way. You can see the HTML. So here's the HTML that makes up the contents of the home page of my blog. You can also see the HTML by saying view page source, right click and view page source. So there's many ways to look at the HTML, but this DevTools thing over here on the right is really nice to know about it. Just a nice interactive way of debugging and analyzing and monitoring what's going on in your web browser. And I typed a magic key sequence to get there, but the way you can get to it is, I think it's more tools, developer tools. I think that's it. But I just turned it off because it was open, but if I do it again, I think it'll open it up for us. Maybe. Yeah, there it is. So forget where I was going with this, but yeah, this, over here you can see I've got DevTools open, and you see that it did the initial get of Miko.html, but then you see the browser implicitly did the get of Miko.jpg to fill in that image. And then some other stuff, I don't even know where that came from, check and add cookie, probably just boilerplate stuff that came along with that website. I should know because it's my website, but I don't. Okay, so if we try to put everything together, we can sort of summarize everything we've seen as follows. You specified a URL, and then you hit enter, and your browser parsed the URL into three pieces: the protocol, the server, and the path. or the how, the where, and the what. Then the browser converted the IP address converted the server name to an IP address. Then it made a connection to the server's IP address using TCP, which in turn was underneath that layer using IP and other hardware connections. And then once it had a connection with TCP, it used the HTTP protocol to send a GET request for the file I named, miko.html. TCP made sure that, well, the whole TCP IP protocol stack made sure that request got where it needed to reliably and intact and, accurately. And the server saw this and it said, yeah, I have that thing you're asking for. And it returned the miko.html file. And again, it used TCP IP to send it back to me. My browser got the response. It looked at the contents of that response, said, yeah, this is HTML. I know how to handle this. And it rendered that, presented that as a document on the screen that looked, meaningful to me as a user, according to the author's specification. So that is really the whole story in a nutshell. And I just want to share a resource with you called glitch.com. I think there's a link here too. I tried to put links everywhere that would let you dive deeper. So if you pull up these slides, you'll be able to visit this. But Glitch is kind of this cool interactive website for both building things, web things, and learning. So this is an example of somebody put together this page, which has intro to HTML, CSS, JS, and Node. So these are different technologies that web programmers should know, and it provides nice little interactive instructional content, videos, and things to help learn those tools. So that's a nice resource to know about. I have a few demos, but let me pause again. Does anybody have any question at all? And don't be shy, because I'm happy to answer anything. Let me check the chat. Looks pretty quiet. Okay, let's do a couple demos. So
I have a question.
Sure.
Wait, can you hear me at all?
Yep, I see you. Hi, Teshi. I'm not hearing you.
Wait, can you hear me?
Now I hear you.
Oh, okay. Wait, I can ask my question?
Mm-hmm.
Okay. So at the beginning, when you're talking about the IP addresses, and like how you can look up like someone's precise address, well, not address, but their location. Do you know like how that affects like people's like personal data or like the security basically of someone's computer and information?
Yeah, it's a good point. You can find, I think you can find location data from someone's IP address, and that's not like a Google or a Facebook thing. That's like a property of how the internet is built. So that is something to know about. Like if you're on your phone and you're browsing, any computer that you connect to, in theory, can figure out roughly where you are. It's not able to figure out exactly where you are. The cell phone companies know exactly where you are, but that's not visible readily to other people on the internet. But they know like that you're, for me, like that I'm in the UK and I'm in the town near. So that is, as far as I know, not possible to hide. Well, I shouldn't say it that way. A casual user can't conceal some of that information, but there are ways to obscure that, like depending on how you access the browser, and you could have in your house, for example, a front end that uses another protocol to hide the actual IP address you're using. So there are ways to conceal some of that information, but it's probably mostly limited to the approximation of where you are in space. Nothing more like your name or phone number or anything like that.
Cool, cool. Thank you.
Mhm. Any other questions before I move on? Okay, just interrupt again if you do have any. So I wanted to show you a couple of quick demos. One I want to do is called Be the Browser. And the main idea here is that a browser is nothing more than a piece of software, a program that knows how to do these tricks I've been talking about. And so we can sort of simulate a browser. Before I do that, let me show you a URL that I sometimes use. It's example.com. And it's just a sample domain that's set up so you can test various programs just by hitting that URL. And you know you'll get something back. It's nothing fancy, but it's just out there to use as an example. So we're going to use a command line to sort of simulate a browser. So I'm going to use a tool called Telnet, which gives you the ability from the command line to make a connection, a TCP connection to a far end host. So it's almost like entering a URL in the browser, but we're doing it at the command line. And everything I want to do in the conversation, I'm going to have to do myself. Whereas the browser would just take care of all the protocol, the HTTP protocol for you. So I'm going to say telnet to example.com. That's the site I just showed you. And remember, I talked about ports. That tells you, what service on that machine you want to talk to. We're going to use 80, which is the default for HTTP. So what that just did is it went to DNS and it translated example.com to 93.184.216.34. And it used TCP and IP to make a connection. So I've got a connection now to that computer. And anything I type will get sent there. But there's no high-level protocol going here. There's no HTTP protocol being implemented for us. That's what the browser would add. So I'm going to make believe I'm the browser, and I'm going to do get / that's the piece of, that's the file or the location I want to get from example.com. And then I have to specify the version. So I'm going to say HTTP / 1.1. That just tells the server, this is the version of HTTP I'm speaking. One other thing I have to do is specify the name of the host. Now that might seem weird because I already specified example.com in the connection, but remember that got turned into an IP address and that information got lost. And the server could be serving multiple hosts, could have the identity of multiple different hosts. So I have to tell it which host I'm wanting to talk to. So I'd say host : example.com. And now if I send one more return, I get back the HTTP or the HTML content for that. Actually, this is the response, 200 OK, that in HTTP protocol means no problem. I found what you wanted and I sent it to you. These things with colons are all kind of meta information about the thing I requested, like, when it expires, how long it is, content length 1256, blah, blah, blah. But the actual content starts here with this doc type HTML. And just to show you, this HTML is does exactly what you would expect it to do. I'm going to break out of this telnet session. And I'm going to open a new file. And I'm going to paste that HTML that we just saw into this file. And then I'm going to say open test.html, which tells the browser to open this file and interpret it as a local HTML file. And you can't see it because it just popped up on my other screen, but let me see if I can move it into view here. That's weird, it doesn't want to. Okay, let's try it this way. Let's move, oh, I know why. Okay, because I was full screen. Let's try that again. See if I can drag it now. There we go. Okay, so this looks just like the site I visited a few minutes ago, but as you can see, it's pulling the HTML from a file that's local on my Mac laptop. So just to kind of review that, I did this. I wish I hadn't cleared the screen. I did this telnet and I said I want to get slash, and I want to use the 1.1 version of HTTP, and I want to tell it I'm example.com, and it gave me back. And this is a good example of some bigger information, more than just like the string get slash. This is an actual payload that is a little bit longer, so it might have caused it to be chopped up into multiple IP packets. In reality, this isn't that big either. You'd get a lot of packet fragmentation if you were asking for a big image or a video or something like that. But anyway, hopefully this is helpful. This part of the document is the what we call the CSS, the style sheet, which tells it about presentation aspects like color and size and stuff like that. And then the actual HTML for the content is here. You see this H1 again, and then the P paragraph text. And here you see a link, a hyperlink. So we see that A element again. Okay. Probably beat that one to death, but I just wanted to make it clear that, the browser is just doing these steps, and you can almost simulate them by yourself by just doing them manually. Nobody would want to do that, but you could. The next demo I want to show you is called Be the Server. And instead of simulating the browser, I'm going to simulate the server. So this one I'm going to use a service called Replit. I don't know if you've used this before, but it's a really nice kind of interactive playground for running code. And it works really nicely with web stuff as well. Probably that's too small to see. Let me make it bigger for you. So what I have here, and it's too big. What I have here is a small Python program. I mean, it's 15 lines, including a couple of blank lines. But what it's doing is it's implementing a very simple web server. This package I import here called Flask is really nice for doing web services. I define a function called say hello. And what this does is it grabs the parameter name if it exists, and then it prints hello and that name with a random background color. That's what this random color is doing. So I'm not stepping through every line of this code, but I just want to, and if anybody wants to, we can dig into it after we're done. But I just want to give you a high level sense of what this is doing. And then this app run says, okay, take that function that we defined here and run it on port 8080. So why didn't I use port 80 since I just told you the web uses port 80? Because port 80 might be in use already by a real web server. This is my fake web server, and I just want to use something else to stay out of the way of the real web server. So I'm using 8080. And now we can click run and see what that does. So first, it's installing some dependencies. And it figures those out automatically, which is nice. This will take a little bit longer. And then I should get a message saying your web server has started and it's running at this address. And then it actually pops open a web browser for me. So there I see hello world with a green background. If I reload the browser window, I get the same thing with each time with a different random background color. So it's working as we expect. And this part right here is showing me what the browser's sending. It looks familiar. Get slash the top level location of this server, and then the protocol version HTTP 1.1, and it got back a 200. Okay. And I think I can even add a parameter to the end of this. I guess I do edit. Maybe not. I was hoping I could change this, but I don't think I will be. Actually, here's what I'll do. I'll just go into a separate browser window. And so this is publicly available on the internet. It's not like it was only working inside that Replit environment. And what I wanted to show you was if I wanted to, I could add a name. I think it was name equals Howard. And it says, hello, Howard now. So that's just showing you a little bit of extra functionality I added to that program. But effectively, this is a web server. It's a very simple web server. It doesn't do very much useful functionality, but it's still kind of cool that you can build your own web server in, 12 to 15 lines of Python code. Okay, so that's what I call be the server. A couple other things I wanted to show you. Web scraping is a tool that you can use to gather information on the web. So let's imagine there's a web page out there and it has a list of something. Like the example I gave here was there's a site called the house.gov/representatives. And it has a link for every representative in the House of Representatives. And you could write code like this that would parse that HTML automatically, programmatically, and produce a list of all the members of the House of Representatives. So basic idea is anything you can see on the web, you can write a program to grab it, and we call that web scraping. And that's a really powerful tool. It's always a little tricky to get it perfectly right because the web documents, the HTML is always changing and stuff, but it's good to know about that tool. Underneath all of this network infrastructure is a whole bunch of submarine cables and terrestrial cables all over the world. It's kind of mind-blowing, but all this stuff is out there, and that's how the data gets, from one country to another across the oceans and all that stuff. And there's a site here that you can click through, which has information. You can click on different countries, different regions, and find out more about the cables and who owns them and some of the history of those. But that's all out there and just working all the time. You don't even, again, another thing you're not even aware of. This is a really cool tool called Traceroute. And I just realized I'm like way over time because I wanted to give you all some time for Q&A. Let me do this one real quick. What this lets you do is actually figure out how traffic is flowing across the internet. So, for example, if I do US Seattle to, I'll say UK where I am. Is it England here? Let's just go to Ukraine because I can't find UK. We can say geo route, trace this. And while that's thinking, I don't think I had too much more here. Yeah, I'll just kind of jump to the end here because I think that covers most of what I wanted to share with you. And I would like to give you a few minutes. I apologize for cutting this so close, but I would like to give you a few minutes for any questions you might have. And while you're thinking about questions, here's the trace route for what I specified. I said Seattle to someplace in the UK. So you can see from Seattle, it goes to Salt Lake, and then Denver, then Kansas, then Chicago, Cleveland, Toronto. For some reason, it pops up into Montreal. Then it jumps across the ocean to Liverpool, then Amsterdam, Frankfurt, Munich, Vienna. Oh yeah, it wasn't the UK. We ended up going to the Ukraine. It's amazing. It takes 17 hops to get from Seattle to Kiev. And you get a running count of how far it's going. And I think you can also get information, like how much accumulated time and how long each hop to hop took. So, and you can zoom in on this thing. It's really cool and see all of the links along the way. So hopefully that's fun to see and gives you a little bit of more visual sense of what's going on. Let me shut up now, like I said, and give you any last chance for questions here. Did I put everybody to sleep?
No, you didn't. We're still here.
Okay, good. Well, if there are no questions, I just wanted to mention that my email is mco@google.com. And if there's something I can help you with after the talk, or you think of a question you didn't think of but really want to know, feel free to email me. I'm always happy to help. And yeah, I'm happy to come back anytime to talk about any other stuff you guys might be interested in. So thanks for having me.
Thank you for coming. That was a great talk. It was very interesting. And yes, I have learned some of it in my like intro cybersecurity class, but I think most of the people here haven't took that yet. So it's very, I enjoy the talk. I hope others
Good.
enjoy. Oh, you
I'm
can do
glad you liked.
emojis on here now? I did not know that. Wow, that's
Sorry.
cool. Oh, she did like a emoji reaction,
Oh,
and I
okay.
didn't know you can do those now.
Yeah, I didn't know that either. Yeah, I mean, even if you've seen that stuff before, hopefully it was a nice refresher for some of the
Yes,
folks.
yes, it was.
Well, thanks to Teshi and Malaya for hosting me. It was really nice coming to your school. I gave a talk to one of the other classes about interviewing topics, tech interviewing. I do a lot of stuff with cloud computing. So if there's any other topics you could use help with, I'm always happy to come back and do another talk for y'all.
That'll be great. I just wanted to remind everyone of our socials. We're on Twitter and Instagram at DSC Howard U. So make sure you follow us on our social media pages as well as join our Slack channel. Teshi, could you put that Slack channel link in the chat for me, please?
Yeah, give me 1 second.
Yeah. And I also wanted to remind everyone that we're also having our first ever, well, not first ever, but first Final Friday event this school year happening tonight at 7 p.m. We'll be having a movie night on Zoom, and you can find a Zoom link for that in the Slack channel and also in our link tree on Instagram if you would like to come to our movie night tonight. Yeah, I can tell y'all, we're watching Venom tonight. So if you're interested in watching that with us, feel free to come out. If there are no other questions or comments, that concludes the end of today's Tech Talk. Once again, thank you all for coming out, and I hope to see you all tonight.
Thank you so much, Mark. Thank you so much, Malaya. This was a great presentation.
Thank you for having me. It's a pleasure.
Have a nice rest of your day.
You too.
Bye, everyone. Izu, did you have something that you wanted to say? I don't know if you can hear me. Okay.